Hello, my name is Bob Duffy and I'm going to be presenting financial modelling in Power BI for SQL Bits 2020. Before we get started, I thought I'd explain a little bit about myself, my background. So most people have probably seen me at SQL Bits. I've been a very long-standing kind of member. I've been in the industry for about 30 years or so. I'm a SQL MCA, or SQL Ranger, MCA, MVP, all that sort of stuff. But what you probably don't know about me is my actually background is financial accounting. So I actually have a degree in accountancy initially, and I spent a large time in my career working with financial accountants to not necessarily on core finance GL, but on a lot of aspects of kind of core finance and banking, such as liquidity, ERPs, and so forth. And my kind of job role kind of nowadays is I manage teams of people building kind of data warehouses, generally on top of ERPs, SAP, M3, and so forth. And financial accounting and reporting is a big part of that. So this really comes from my experience of the real world building financial BI systems on top of ERPs. So what we're going to cover is a brief look at what I define as financial reporting, because it's quite kind of a vague term, and then 6 challenges that kind of make it different than other types of BI reporting. And that's really the kind of bones of the presentation, is what do we have to do that's different on financial reporting versus our normal BI reports that we make. So starting off, what is financial reporting? Well, typically, when we implement finance within an ERP, for example, we'd split it into a number of modules. Okay, you've got your GL kind of module, or your general ledger, which is for me is the heart of finance. I mean, that's from what your profit and loss, balance sheet, cash flow, and most of your core financial reports are going to go. And then you've got your specialist kind of modules, AP, or accounts payable. Who do we owe money to? Accounts receivable, who owes us money, and various modules and analytics about the financial aspects of stock, depreciation, price variation, and so forth. Now, obviously, for today, that's a very wide area to focus on a 1-hour presentation. So I'm just going to focus on the general ledger, and we're going to home in on the profit and loss, because really most of the other financial reports are a variation on the profit and loss. Okay, so but the 3 reports that we typically call the holy sort of trinity: profit and loss, balance sheet, and cash flow. I mean, these all come from the same structure, from the general ledger structure. So once you've implemented these 3, you've pretty much got a good core finance module that you can sort of build on. So let's look at some of the challenges of profit and loss, or income kind of statement, as the Yanks call it, right? Well, we're going to go through this in a lot more detail in the rest of the presentation, but what I've put on the right hand side of the screen here is the sort of spec that you might get from a team of financial accountants. So they might draw up a draft in Excel, and they'd have probably done it using VLOOKUPs and macros, but at the heart of it, you'll have base roll-ups which come from this thing called GL codes, or account codes. So every time something's posted into the general ledger, it's stamped with an account code, okay? And there might be natural rolls up. So everything that has an account code of 4,200 goes into trade sales, for example, here, right? Then you'll have some aggregates. There might be subtotals, but these are actually first-class part of the report, and there might be some custom aggregates. So, for example, net invoice sales is gross sales minus discounts, net sales is invoice sales minus returns, and there'd be some key performance indicators that might be a first-class part of the report. A classic one, which is very popular nowadays, is EBITDA, or EBITDA if you're including depreciation, and that's basically the profit but excluding interest, tax, and maybe amortization. So excluding things that the company really doesn't have any control of. What is the controllable profit? Okay, and for most people, they're going to be benchmarking companies based on their EBITDA, right? because I mean, high interest is just going to be a sign that you own lots of kind of property or something, which is sort of gaining interest. It's not really a sign of how your core business is kind of running. So people are more likely to be looking at EBITDA than they are at profit, really, right? So on the screen here, you can see the sort of challenges that we're going to run through. So let's go a little bit deeper into them. On screen here, we have the typical data structure that you would get if you imported a general ledger into Power BI. So I've actually done exactly that. So I've taken the AdventureWorks, which is freely sort of downloadable, and we get this sort of table structure here, right? So we have the chart of accounts, which is the core one, often called the GL codes. So every time anything is kind of posted into the general ledger, it's going to have an account code attached to it. We've also got other dimensions that help describe the kind of general ledger posting in kind of lower level detail. Now, AdventureWorks doesn't have too many kind of dimensions, but most of our customer ERPs would have, say, for example, customer group, kind of product group, some way of breaking down the general ledger posting. Also, within AdventureWorks, there's only a single general ledger table, but most ERPs would have a couple of tables because you might have sort of budget as a separate table. You might also have a balance where rather than have to sum up all of history in order to get to the balance, there'd probably be a balance table as well into a larger ERPs. But the core concept is exactly the same. So if we look a little bit deeper at the chart of accounts, in AdventureWorks, this is what it kind of looks like, right? So every account has a 4-digit code, which is actually fairly typical in most finance kind of systems. A GL code will typically be 4 or 6 digits long, right? You'll have a name for the account, and these codes will be very categorized. So financial accountants tend to be quite kind of rigorous in how they allocate it. So certain groups of numbers would roll up in the same way. Much like if you chat to a network professional, how they allocate IP4s, right? Now, in the AdventureWorks case, it's a parent-child hierarchy. So you have this key sort of structure, and it rolls up. I have to say that although AdventureWorks is this way, and some accounting packages, I think, QuickBooks has some degree of parent-child, no major ERP that I work with has the chart of accounts on a strict parent-child basis. It's usually done on roll-ups to very specific groups, okay? But let's start off with the parent-child approach, okay? So what I've done is I've taken the basic tables and imported them into a Power BI model, and the first thing we've got to do is take that parent-child hierarchy structure and flatten it out. So if it's got 6 levels, we have to actually create level 1, kind of level 2, and all the way up to level 6. So the functions now built into Power BI, these sort of path kind of functions, right? So I'll just show you a demo of what some of those actually look like, right? So let's, here's a Power BI model. And what I've done is I've just literally gone get data, pointed it at the SQL kind of data warehouse that had the general ledger tables in it, and I ended up with this here, right? Now the bit that I've now added is I've added the hierarchy functions to take care of the parent-childs. So if we go to the tables, and to the account table, you can see there's the natural data that comes through, and then I've added account path, which is a path function. And this really shows me each of the keys involved in the kind of level. And then I'd use, for each of the levels, I would use the path item to extract which kind of key that is. So, and then for level 1, I'm using the path item pointing at 1, and then do a lookup to find the name, and then doing the same for 2, 3, 4, 5, 6. So I've now naturalized, as they call it, the hierarchy into something that can actually produce a proper hierarchy in Power BI. And I also use the path lengths to store the kind of depth. Now I'm actually doing this within kind of DAX by using kind of calculated columns. In a lot of systems, I would be tempted to do this in the relational kind of database as well, because that means that we can use it in other platforms other than kind of Power BI. But let's stick to doing it in kind of Power BI. The end result then is I can use the matrix control to automatically render the hierarchy, right? And it's quite easy to work with. If I was to do that from scratch now, I can go to here, go to my fields, drag on my general ledger amounts, switch to matrix view, drag on my account, drag on my hierarchy, and you see I've started to get the bones of my report here, or I haven't done any formatting or anything. I can start to see what that looks like, and then I can maybe filter it by the report, right? So let's just give me the profit and loss one, for example. Okay, so let's move on. The next problem we're going to deal with is signage or unary operators, right? So what you will notice, I didn't go into too detail as to the numbers, but I'll bring it up on screen again, right? Just so you can see the numbers that I got are actually completely incorrect, right? They don't make any sense whatsoever, right? So the first example, I had sales totaling 1.68 million, costs totaling 700,000. So you'd expect, profit is going to be the sales minus the costs, but it's added them all up. And the reason that is because when we extract all of the data out of the ERP package, everything is stored as a positive, right? So it knows whether it's a negative by the type of account. If it's an expense account, a positive actually means a negative. So this is one of the confusions with sort of debits and credits. In some cases, a debit is what we think of as a positive kind of value. I've sold something. In the other side, a debit could be a positive value to an expense account, which is a negative value from a reporting perspective. So we need to invert all of these signs to get the correct kind of signage. Now, there's two ways of doing this. You can either do this in DAX, or I prefer to do it way before that at the ETL time, so I'll get a clean set of data before I start. If you do want to do it in DAX, there's a great link there to where the Italians, the SQL BI guys, have an example of how to do that. But I'm going to do it before that at the Power Query stage. As I said, I do usually prefer to do it even earlier if we were importing it into the data warehouse. If we were creating a data warehouse, as part of that creation of the kind of data warehouse, I'd probably invert the sign so that we could run relational queries that did exactly the same as the BI platform. But let's just see a quick demo of that in action, right? So here we have an example formula. I just literally go into Power Query, type in the formula, and get the correct figures out. An important lesson here is that when you get the spec from the financial accountants, you get a real set of numbers if you can, right? So that you can actually check that each stage of the report is producing numbers that make sense. So if I just flip over to the model, I'll give you here's one I prepared earlier, you'll see that what I've done is gone into Power Query here. In the general ledger, I've added a step, and the step is just really applying that formula now so that the base amount gets its sign inverted, right? So the amount, you see these are all positive to start with. After I apply the operator, I should get some of these as, there we go, see the base amount, I'm getting some as positive and some as negative. So I'm effectively creating a new column there, okay? Now that's that. Once I do that, I now have the correct values that hopefully match what they have on their reports there. Now let's look at some of the other challenges, right? The ragged hierarchy, right? You'll notice that the example in AdventureWorks is a 6-level hierarchy, right? But not everything is 6 levels. So if I look at taxes, for example, taxes just go in one code in AdventureWorks, right? There's no parent. It's just straight in at the kind of tax, which I think is level 2 in their hierarchy. So levels 3, 4, 5, and 6 are blank, and that means on the report I get this horrible looking thing. Now that's fine if I'm gonna take off the plus and minus and I'm gonna manually expand and give them a static report, that's fine. But if I'm creating something in self-service where financial accountants are gonna expand the hierarchy themselves, I'm gonna get that undesirable effect of the blanks on the ragged hierarchy, right? So let's look at different ways of dealing with that. And again, this is covered off quite well in that parent-child hierarchy blog by the Italians there, kind of Marco and Alberto. But let's see a demo of that, right? So again, I've created a 1B. well, I've now applied that logic. So let's look at the before picture. So here I have the before, I've just put on the base amount, and you can see that while I can get the report or I can get the roll-ups, I get this horrible thing here. So the first thing I'm going to do is use that depth to understand what is the max level of each node. So if I go to the account, if you remember, I created this, go in here, account depth. I'm going to put that as a measure and just give me the max depth. You can see I now understand what is the max depth of each one. So when I go to tax, I know the max depth is 2. So the bit I now need to know is, well, what level am I actually at on the report? Because I know that this is level 3, 4, 5, and there's a little plus to get to 6 here, right? So this is where we use the isInScope function. So what I do is I add a calculated measure, and the calculated measure basically checks to see, isInScope, what level am I currently at? So when I add that onto the report, you can see when I come down to taxes, we understand that we're currently at levels 2, 3, 4, and 5. I can now have an if statement that applies it. Now, for simplicity, what I usually do, although it's not the best for performance, is I create a flag, which is a measure that returns a 1, a 1 or a null, based on if we want to hide it. So you can see here, or if we want to kind of show it. So you can see here, I've got a 1 by 1 that should show, everything else should be hidden. And then what I do is I multiply any of the measures shown by that value. The end result is the natural kind of non-empty behavior will not expand on the kind of taxes. And then for reporting purposes, I might decide to hide this sort of plus or minus anyway, right? Because it's not the best icon in the world, to tell you the truth, right? So let's go to row headers and turn that off. That might give me a cleaner look. Okay, so that's how we handle ragged hierarchies. So this is one of the more complex aspects, what I call the pro forma format, our calculated members, our custom aggregates, right? So on the left-hand side, you've got a very naive one that just rolls up the parent-child structure, right? On the right-hand side, you've got the spec that comes from the financial accounting team based on how they actually produce the profit and loss. And what you'll see is although some of the numbers are the same, they're not exactly the same. Some of the main differences are the way that totals are done. They're going to want to see them in a particular way, right? So I want to see gross sales less discounts equals. This is very common in finance, right? Whereas if I just use a grouping, it's just not going to come out like that at all, right? And it's definitely not going to be alphabetical. There's a very strict structure on the sort of P&L. It must be on this kind of basis, right? So we need to have a custom ordering. We need to have things in the right order. And these bits that I've highlighted in yellow are sort of, I don't know if you call them custom aggregates, right? So what we're saying is I want to have a figure as part of the report, but this figure is equal to sales minus the discounts, right? So it's gross sales minus discounts, and this is invoice sales minus returns, right? When we come down to the bottom, here's an example of a very common key performance indicator, EBITDA, right? So what we're going to do is we're going to take the profit less interest, tax, and amortization, and there's another variance, EBITDA, which is also less depreciation, right? And this is probably a more interesting network kind of KPI than profit, because it's taken away, interest, tax, and amortization that you don't really have any control of, and it's really telling the owner of the company what the controllable profit is. So when you're comparing different companies, you're more likely to be looking at the EBITDA than you are at the profit, right? So sticking this on the profit and loss is a very common requirement, right? Now, although when the financial accountants give you the spec, they're going to say, well, this is that figure minus that figure. What we do notice is there's another way of looking at it, is everything comes from a GL code. So we can actually say that the EBITDA is just the sum of all of the GL codes before this, and the same goes for each of these a lot of these are just really cumulative subtotals that are put on the report. Okay, that's really all they are. So you don't have to express them as individual calculations, right? You can, but it's a bit more complex. So we're going to treat them as subtotals, custom subtotals where it's grouping one or more groups, and cumulative totals are running sums. Okay, so how do we do that, right? Well, there's a few different ways of doing it. You could, like in the MOLAP world, you would have used scoped assignments to have calculated members that have special formulas, right? There is an equivalent in DAX of the calculation groups. You could have a crack of doing it that way, but you'd get some pretty nasty DAX, right? So I tend to do it by some different thinking, by trying to resolve this type of complexity from a data modeling approach. And to show you an example of this, what we do is we break the requirements of how the report is structured down into two things. One, reporting ranges, right? So for each line on the report, what section does that come from? What heading does that come from? And we make it a fixed two-level hierarchy, right? So there's no such, so it's no longer a ragged hierarchy. There's always two levels, right? And then we define whether it's a simple sum, where it's going to sum up the account codes under that hierarchy, it's a running sum, or it's a custom calculation, which is summing up other arbitrary members of the report. Okay, so there's only with those three different things, I can now just say that my various elements of my report, like my profit before tax, my profit after tax, and my EBITDA, are now just simple running sums up until that point, right? And as long as I've numbered them correctly, I also get my correct ordering. We then define the account rules that say how different account numbers map into the report sections that are going to be rolled up. Okay, and if we're lucky and the accounts have been designed, there'll be a from and a to, and it'll be a range of numbers. If we're unlucky and there's a broken range, we might have a couple of lines. So for administration, it's not a simple range, because you can see that 6920 is in administration, but 6810 is in depreciation. So I can't say from 6,000 to 7,000 is administration. It wouldn't be that simple. But I can define a range of rules. I bring those tables in, and then I create a bridging table, a many-to-many table between the account codes and the report. So here's an example. Now, I currently don't do this in Power Query, I have to say. Most of the times I do this in a stored procedure. The reason I have is because SQL stored procedures have this between clause. So you can take a from and a to expand kind of data out. I'm sure there is an equivalent if you were just doing a pure Power BI solution and didn't want to have any relational queries at all. There probably is an equivalent, but I was lazy and used kind of T-SQL because most of my solutions have that underneath it. So we create three different types of inserts into a many-to-many kind of table. One is the basic sums, two is the running sums, and you see the join on the kind of running sums is going to put all the numbers before that, and custom roll-ups, where we're going to take everything in a group. And when we do that, we end up with this type of Power BI kind of model. So it's no longer a parent-child hierarchy. We're no longer using the account for our report. We now have something above the chart of accounts called the financial report, okay? Or sometimes we call this account ranges, whatever you want to call it. And there's a many-to-many, so many items on the financial report can be linked into the same account code. This also solves the problem of report variations. So one of the misconceptions that people have about things like kind of profit and loss is that there's one standard for profit and loss, and the whole organization has a single profit and loss. As you get to larger organization in different companies, different divisions, different focuses, manufacturing versus something else, you'll find you get to people start pulling for different versions of the profit and loss. So they might say, well, I want price variation to be a first class line item. I want something to be above the line in determined EBITDA or below the line, right? And there are different variations. Now, obviously, most people want to stamp those out. But sometimes my job, I don't have the political clout to reform how a customer does their finance kind of systems. My job is just to implement what they ask me to do. And they're like, well, I want variation A for profit and loss here and variation B here. So this design helps us achieve that because we can have multiple versions of the profit and loss. It's not just one, right? So let's see this sort of many-to-many concept in action then, right? So here we have the hopefully final version where we have that exact structure there. When I look at the tables, the financial report looks like this. So it tells me what the operator is, what the report number is, and I have a report heading and a report section, okay? Then the many-to-many table, which I've hidden, what do they call it? Report account map, is now just a 2-column table that maps from the account key to the report number, or the report key if it's got a surrogate, right? Once I do that, I then go back to my report, and now rather than use the parent-child, I use the report heading and the report section and the account. Now there is a little bit of dealing with ragged hierarchies because some of them are 2-level and some of them are 1 kind of level. So if we look at EBITDA, for example, that's only a single item. We resolve that in the exact same way as we did for the parent-child. And now I've got something that kind of looks much the same and functions in the same way as what we were requested to on the requirements. And if you compare those two, here's the original spreadsheet that we got, and we see that's kind of the same. There's some slight differences in the operating expenses. We have the kind of subtitle at the top and they've got it at the bottom, but other than that, it's pretty much the same, okay? Now, one of the bonuses of this now is I can hopefully produce a solution which is transparent to Excel as well, right? So I go to my cloud-based powerbi.com where I've sort of published my P&L report to, and a financial accountant might want to do their own slice and dice, so they can analyze in Excel. Open that up. Up they come. And now if we've designed it correctly, with just a few clicks of the mouse, they can actually get a profit and loss. So I can go to my general ledger, bring on my amount and my budget, and I've added variance percentage here as well now. And then I go to my financial report to bring in, now I can have a hierarchy just for that, or I can decide how I want to do that. Now I'm just going to bring in the heading and the section independently, and you see, hey presto, on screen I've now got a profit and loss, okay? I can customize this as an example. Rather than comparing to budget, I might want to say, well, let's go into the date. Let's select a year, fiscal year. And the data's quite old at this point. And then I might say, right, I want to see what the profit is over the course of the fiscal periods, right? So now over the course of the fiscal periods, I can say, well, how has the profit and loss changed? Am I increasing? Am I going down? And so forth. So quite a lot of the slicing and dicing, as they call it, financial accountants will prefer to do that in Excel. And this design allows them to seamlessly go between Power BI and Excel. Okay, so let's look at the final thing, which is, flipping back to here, dynamic allocation and drill down. So next we're going to look at some of the types of analytics, drill down, and what we call dynamic allocation that you can do now that you've got your general ledger structure in place. So there's two, one of them is easy and one of them's hard, right? So the easy one is if you're doing analytics by a key that's in the general ledger, and generally as part of the design of the general ledger, there'd be keys that the financial accountants deem important, like, you know, product group, kind of customer group, and stuff like that. So if you're doing analytics by those, it's generally quite easy. When you're doing analytics by something that's not part of the general ledger, that becomes harder because you have to allocate the figures down by using some sort of allocation algorithm. So I'll show examples of both of those, right? So let's flip over to Power BI. Here we go. So the first thing that you can do to put the eye into sort of business intelligence is to add the sort of brushing effects, right? So when I click on administration costs, for example, I can see a waterfall chart to split that by country. And if I was looking at this maybe over all time, I might see more countries in there. And what you might see is that which countries are contributing the most to the variance. Very common that what you see is, maybe this was by department, that one department had a positive variance, another one might have had maybe a negative kind of variance. So this sort of variance analytics is very common with P&L or balance sheet, showing the time kind of series across here, obviously. So when I pick a particular year, I can see a breakdown of that. So I can see if I'm having a particularly good month or a bad month, and being able to right click and drill down. So if I look at EBITDA, for example, I can drill down to see, well, show me the EBITDA by department or by any of the keys that are related to the general ledger. Right, so this is kind of the easy analytics. So here we go, by department. So I actually see that most of my profit is coming out of the R&D department. The rest of them are pretty much cost centers rather than kind of profit generating departments. And I can see the breakdown of that as such, right? So that's quite interesting. So adding these types of analytics will drive the finance team to consider using Power BI more than their traditional just sort of tabular data in Excel. Now let's talk about overhead allocation. So when I come down to something like expenses, for example, I might have overheads, administration costs, right? Now these could be booked in at the top level. So I pay for rent, right? Rent, I just get one bill. I don't know how much rent I paid per product that I'm developing or per warehouse I have. I might not even have that much kind of detail. So to report it at that lower level, I have to use some weighting to allocate that number down. Now, traditionally, this is usually done inside the ERP. They might have some sort of module to sort of allocate overheads down, but sometimes they don't, and it's either done dynamically as part of the report, or it's done as part of the ETL stage within the data warehouse. So let's have a look at how we do that. So as an example, I've got product allocation. I want to know the costs per product that I make, right? So the first thing I do is I decide what the weighting is, right? If it was something like rent cost, I could say, well, the size of the product, because that's going to determine how much I have to store. In this case, what I've done is I've taken the product cost, right? So I know what the product's costs are of what's sold, and I'm going to create a product ratio, right? So if I just drag product ratio on here, you'll see this is going to tell me the breakdown of how the products contribute towards the total product cost, and I can use that as a ratio to allocate the general ledger amount for the selected item that I'm looking at, right? And this would allow me to drill down to see that all, okay? So the formula for the product ratio, I'll show you that on screen. Top here, you can see is this here. It's quite simple. I'm just really getting the kind of product cost and then dividing that by all of the product cost over the entire dimension. So that's your normal sort of product ratio kind of formula. And then for the product allocation, I'm just allocating the GL amount, multiplying that by. I have inverted it because we're usually looking at expenses, and I might want the numbers to come out as positive on top of the analytics, right? So now once I've done that, I can get that desirable behavior where I'm in the P&L statement, and I can right click on my administrative costs and drill through to see the allocation of that particular cost by product. And also I might see it by account as well. So these are the actual account codes that make up administration. So I can say, well, what share of costs am I going to give road bikes? So road bikes are going to pay this much, and mountain bikes are going to pay this much. And if I was to change the interactions, I could say, hey, show that as the brushing effect, so that I can now, as I click here, see the percentage of my costs that are borne by a particular area of the product. Okay, so that's an example of overhead allocation. And the end goal that we're looking for is to make an interactive profit and loss that someone can start to drill down and do analytics of, rather than just the kind of pro forma statement that a piece of paper might have. One type of analytics that we've had great success for is the decomposition tree. Now, when we sell it to the finance team, we tend to call it an explorer. Okay, so an example of that again could be, I could be looking at EBITDA, and I'll drill through to see it by the explorer. Now, the explorer is just a decomposition tree where I've taken the dimensions that you could analyze it by and put those as possible ones to explore it by. Okay, just to show you that in the design. Okay, Data Explorer, I've just literally dragged on a decomposition tree, put on the GL amount or the allocated amount, and said what the possible areas they can explain that by are, and then we leave it up to the business user to decide how they want to use it. So I drill through to the Data Explorer, and now I can see, hold on, let's pick a particular figure. Pick this EBITDA. Here we go. Oh, I've got a filter on, have I? Report, isn't it? Reports, the report section shouldn't be administration, there should be EBITDA. Try that again. And I can take that amount of the cost, for example, and drill that down to say, how do I want to break that down by account? So I can see which of my accounts is, I probably want to go from high to low actually, hold on. Click on the plus, low value. That's better, right? So I can now say by account, so trade sales is probably where most of the information is, where most of that is coming from. Then I can say, well, show me that by department. Okay, so the R&D department is where most of that's coming from. Split that by country. Okay, I see how that breaks down by country. And then finally, I might say, show that by product breakdown, by product subcategory breakdown. Once I've got to that figure, break that down maybe by month. Okay, so I can see for my EBITDA, I can see where I've got my my best breakdowns there. Okay, so this sort of analytics proves quite popular because how it's used is up to the end user rather than being a canned report. Okay, let's flip back. Now we've pretty much finished with the profit and loss. Let's just take a quick look at some of the other reports. So big one is probably the balance sheet, right? So how does balance sheet differ from the profit and loss? Well, let's look at the data model, right? In a lot of cases, it will come from the same data model, but the difference being the profit and loss is the amount of profit I've generated in this period, whereas the balance sheet is the cumulative value of assets. So you're going to have the concept of an opening balance, movement, and a closing balance in exactly the same way as you would with, say, for example, a stock control kind of system. As I mentioned before, you can either get it from the general ledger by summing it up, but some ERPs will also give you an actual balance file where each year they might give you an opening balance, and then each month they might give you a closing balance, right? Now, this is put in for performance purposes, and historically, financial systems were prone to corruption. So what this would mean is data from 10 years ago might get lost or corrupted in a vendor update. So having to sum up all the values over all time to produce the results wasn't seen as reliable. So what they would do is have the concept of a closing balance that was actually posted so it could be signed off. So that's why it could be split into two kind of tables. But on smaller systems with great kind of referential integrity, you could just go for a single table approach. The general ledger generally doesn't get that big. Like, it's very rare to find a general ledger with hundreds of millions of rows, even in a multi-billion euro company, right? So let's just go with the AdventureWorks design of a single table and see what that kind of looks like. So as a starting point, I'm going to take profit and loss. So I've got the standard profit and loss from the chart of accounts. Now I'm using the parent-child kind of version rather than the sort of many-to-many version, but we tend to use the many-to-many version for the balance sheet because, again, we can have the complexities of custom roll-ups, special KPIs embedded in the report, and so forth. But let's just take this kind of basic example. Here's the profit and loss. So the first thing I've got to do is to view different accounts, because some account codes are for income and some are for the balance sheet. So if I go to the filters, you'll see that I'm filtering to see the report of net income. And this is actually defined in the chart of accounts that a particular code is for income. But here I'm going to say, no, this is actually a balance. I want to just see all the balance accounts. So now I've got the bones of the chart of accounts for the balance sheet in terms of the rows I want to see, right? But the value is only showing me the movement in the months. So I'm going to need to write some DAX, and I might want to change what, just from the word total, I might want to see something different. So let's deal with both of those. If I go to my general ledger, the first thing I'm going to do is define an opening balance, which I will use a formula that looks something like, screen, this opening balance. I'm going to get a variable to be the current max selected period or date. I use period because most things are posted monthly, right? And then I'm just going to take the GL amount, use all of the date, so I ignore the current kind of filter, and then sum up overall time. So this is a very standard pattern for opening balance. Okay. Once I've got that, I can define the movement. The movement is just the same as the sum of the amount for the selected period, and then closing balance. Now I could go closing balance equals opening balance plus movement, but in this case I'm just going to recalculate the closing balance by summing up all values up until greater than or equal to the current period, right? Once I've got those, I can go to my report statement, take off the GL amount, and then I've now got opening balance, movement, closing balance. Okay, so I've now got the bones of my balance sheet. Done. Okay. Now this is very basic. Obviously, I would probably, for a commercial system, look to define those Excel spreadsheets that we had before. I might actually define versions of these for the balance sheet as well, so I can have that flexible reporting structure where I can have different flavors of the reports. I can have running sums, custom aggregates, and so forth. But for the basic version, this is potentially good enough as a starting point. Okay, so that's a very quick look at the balance sheet, and that's really all the content that I wanted to take you through. So we've had a quick look at the profit and loss. As I said, I've really looked at 6 main issues that I think you'll have most of the time when you want to look at the profit and loss, and how to also apply that to the sort of balance sheet. So just to finish the presentation, I've got a list of links that you might find useful if you want to do any further reading. In the DAX patterns, there is the parent-child. We've got a section on chart of accounts on how to apply the unary operator in DAX. As I was saying, we don't really do it in DAX because we prefer to push that down, but it's an interesting read anyway. This is a very interesting approach. A guy called David Churchwood, I think, produced a blog on what he called the art of the cascading subtotal, and that's a pure DAX-based approach to how to implement that multiple running sums and subtotals within a profit and loss. It's kind of unique to profit and loss. As I said, we took a pure modeling approach using a many-to-many table, and I've now tried that on 4 or 5 like very large customer sites, and I'm very happy with it. But this is an alternative approach, and it looks like it's sort of viable as well. So that's kind of worth a read. And then, of course, the dealing with Ragged Hierarchies. So is in scope is one thing that you can use in your toolbox to help determine that. Finally, if you want to download the AdventureWorks, then feel free. It's freely available, and you can get hold of your general ledger structure to start sort of playing with to see what a P&L or a balance sheet actually looks like. If you do want a copy of my Power BI that I've kind of taken to reverse engineer, I will be uploading that to my blog as well. So if you Google Bob Duffy blog, you will be able to download the actual Power BI kind of model that I've used that has all the formulas already in there. So I'll leave that up for you to download so you can play with that. And if you do have any further questions on that, feel free to either ping me on Twitter. I've got contact details. I'll just put my contact slide here. You can reach me on Twitter at Bob_Duffy. Make sure you include the underscore, or you'll probably get the mayor of Rochester in New York, who's also called, well, used to be called Bob Duffy as well. And I'm sure he won't be wanting any questions on Power BI or DAX, right? Or you can email me actually. I haven't put my email here. Yes, I have here. bob@prodata.ie. So if you want to email me any follow-up questions, I will more than happily answer any questions on this session. Thank you very much.